Welcome to this video. You are probably asking yourself, what is this madness? Atoms and cells in the same slide? Well, you might be right. It could be a little crazy, but this will help us understand better one of the topics of this video. Why? Well, to better understand cells and atoms, we need to use scientific models. A scientific model is just a representation to help us understand complex things or very large objects like planets of the solar system or little tiny things like atoms and cells. Scientific model can also be symbols or equations. For example, here we can see the representation of a chemical reaction that happens inside of a chloroplast. This is the reaction of photosynthesis. Just by looking at these symbols and equations, we can understand several things. For instance, we can see that in order for this to happen, we need 6 molecules of water, 6 molecules of carbon dioxide. In the presence of sunlight, we are going to obtain 1 molecule of glucose and 6 molecules of oxygen. Yes, that very same oxygen that you and I need to breathe in order to be alive comes from this reaction. We wouldn't be here if photosynthesis were not in this planet. At least we wouldn't have the life as we know it right now. Scientific models also help us understand concepts such as atoms. The air is made out of atoms. Water is made out of atoms. Plants are made out of atoms. We are made out of atoms. And here we have one of the models used to represent atoms. In this model, we can observe several things. We can identify 3 different types of particles. We can also see that some of those particles are positive, some are negative, and others appear not to have any charge. And all this just by looking at this little diagram, at this model. Also, we can also deduct that in this central area, let's call this central area nucleus. In this nucleus, we can find the positive particles and the non-charged particles. The positive ones, let's call it protons. This one, the uncharged, let's call it neutrons. And these negative particles, let's call it electrons. And yes, just by looking at this model, we can also see where the negative particles like to hang around, where the positive particles like to be as well in the nucleus, as well as the particles without any charge. See, a model will help us understand better very difficult concepts. And how do I identify an atom? Well, scientists classify atoms or elements according to the number of the positive subatomic particles that they have. In this case, we see 2. So we can tell that this particular atom has 2 protons. And this is what we're going to use to identify our atom. We're going to use a periodic table because all known elements or types of atoms can be found inside of the periodic table. And how do we identify atoms? And this is how the periodic table looks like. Everything that we see in nature can be found in here, in this periodic table, or all the building blocks of all the matter around us is in here. It's a combination of this. Okay, I'm just zooming in a region of the periodic table. Remember our model for the atom that we have here. Let me see if I can make this a little larger. So our atom had 2 positive particles in the nucleus along with 2 neutrons, and outside it had 2 electrons or negative particles. So remember that I mentioned that in order to identify which element are we looking at, all that we need to do is to see the number of positive particles. This one has 2 protons, right? One positive particle and the second positive particle right there. All that we need to do is to look for the atomic number, which is the number on top of the element. This one is a number 2. So this representation, this atomic model, is showing us an atom of helium. So now you have very good information from this periodic table. You know that the number on top is representing the number of protons that gives the identity to the element, which means that any element in nature that has 2 protons, that's helium. There is nothing else. Same for instance carbon. This is number 6 right here. I don't know if you can see it well. So every element in nature that has 6 protons has to be carbon. All right? And this is how we finish. This is how we end our video today. I hope you find this video helpful and you have a better understanding of scientific models and atoms, of course. Thank you.